All right, guys, this is the Chapter 5 review. Couple things. First, it is very long, or it looks long. It's really not that long. We just gave you a lot of space to work through the problems. Hopefully we get it printed for you. If not, I'm sorry, the printer was down. So then you'll have to just use your own paper. But one thing I wanted to point out as you follow along with me, every page has kind of two problems, and each problem on it is very similar. So I will work through both, but if you're feeling stuck, watch me work through the one on the left and then pause and try the one on the right. That way you get a feel for if you can do it on your own for the test. So try to pause it in between and give it a chance yourself. Another quick note is on my version, there is a mistake right here on problem number 2. This should be a subtract 4, not a plus 4. So hopefully I get that fixed on your version, but just in case if not, that should be minus 4. All right, so let's go ahead and get started. Number 1, so they give us a function in vertex form, and they want us to find the vertex. I think you guys are pretty good at this now. We're going to take the opposite of that 3, so -3. The k, the -25, stays the same. So there's our vertex. And then they say rewrite it in polynomial form. So again, they're talking about this same function right here. I'm just going to bring it down so I have it in front of me. F of x equals x plus 3 squared minus 25. All right, so in order to rewrite this in polynomial form, the notes say to multiply and simplify, but just a little bit more detailed. What they mean by that is they want us to first expand this square here. So we're going to have to change this to x plus 3 times x plus 3 and multiply that. Don't forget, we're going to keep that minus 25 there. So we will distribute, or not distribute, we're going to expand this here like that. So that's going to be x squared plus 3x plus 3x plus 9, still minus 25. Combine our like terms right here and right there. And we have x squared plus 6x minus 16. So that is our equation in polynomial form. All right, so again, we expanded our square, then we combined like terms. All right, so next they want us to write it in intercept form. Well, we need to start from polynomial form, which we just found, so I'll bring that down. And they give us a hint right here. I don't think they'll give you a hint on the test, so make sure you know that you remember that to do this, we're going to use the big X. So -16 on the top, 6 on the bottom. And let's think of things that multiply to 16. 1 and 16, 2 and 8, 4 and 4, and that's about it. So which one of these is going to go to 6? Add to 6, it's going to be the 2 and the 8, and the 2 is going to have to be negative. So those are our numbers right there, and we'll put those into our equation like this. F of x equals x minus 2, x plus 6. So we just put them right in just as they are, and that is our equation in intercept form. All right, from that same work, they want us to identify the intercepts. So here's where we'll take the opposite of those numbers. So our intercepts will be 2, 0, and -6, 0. So always make sure with intercepts, you should have 2 points, so make sure you're listing both of them as points. All right, again, if you haven't paused it, pause it and go ahead and try number 2 on your own. But I'm going to keep going. It's up to you to pause. All right, so find the vertex, same thing, take the opposite of your h, so that will be +6. The k stays the same, so -4. Rewrite in polynomial form. So I'm going to write what I'm starting with. I'm going to expand this one a little different. There's another method that works better for some of you, this box method. You can do either method, but I wanted to show one way of each. So this x minus 6, well, so first of all, this is x minus 6 times x minus 6, and then still minus 4. So I'm kind of crowded here. So that x minus 6 times x minus 6, I'm going to use the box method to expand it. So in each of these squares, let's see, the top left square will be the x squared. This one is minus 6x down here, also minus 6x, and then this one will be a positive 36. And then I can put all my terms together, the two diagonal ones right here, combined, they're both like terms. So all together I have x squared minus 12x plus 36. Don't forget I still have that minus 4. So I'm almost done. I still have a couple terms to combine, some like terms to combine there. So all together I have x squared minus 12x. And then it would be plus 32. All right, that's my f of x there. All right, so there's my equation in polynomial form. All right, so let's go ahead and write this in intercept form. So same thing, we already have it in polynomial form, so we'll start there. We're going to use our big X. The 32 will go on the top, and the negative 12 on the bottom. So things that multiply to 32. 1 and 32, 2 and 16, not 3 and anything, 4 and 8, and I think that is it. Okay, so to get to 12, it's going to have to be the 4 and the 8, and they're both going to have to be negative. So that should be my numbers there, so it will end up being f of x equals x minus 4, x minus 8. So there's my equation in intercept form. And then we can find our intercepts. We take the opposite of both of those, so it will be positive 4, 0, and positive 8, 0. All right, next page. All right. Same thing, this time it's just a little bit more complicated. If you notice, we have an A in front on both of them. So it's just going to be a couple more steps, but most of the process will be the same. First off, though, they want us to find the vertex. That's exactly the same. The vertex here will be positive 1, comma, negative 18. And then rewrite the function in polynomial form. So I'm going to write what I have. F of x equals 2 x minus 1 squared minus 18. So same thing. First thing I'm going to do is expand. So everything else will stay the same. The 2 will stay there, but my x minus 1 squared will become x minus 1 times x minus 1. And I still am subtracting 18. So I'm going to do my expansion here. And let's make sure I get everything right. So we still have our 2. Inside my parentheses, I'm going to have x times x is x squared. Negative 1 times x is minus x. And then the other negative 1 times x is minus x. And then my negative 1 times my negative 1 is plus 1. So I should have 4 terms. When you multiply those two things together, you should end up with 4 pieces. 2 that will combine, and then but all together there should be 4. And then subtract your 18. So we do have these 2 that can combine here. So let's do that. X squared minus 2x plus 1. It seems like a lot of steps, but we're just doing one thing in each step. It takes up a lot of space, but if you just do one thing in each step, it's a good way to make sure you're not missing anything. All right, let's distribute this 2 to each of these pieces. So I'll have 2x squared minus 4x plus 2. And then we still have our minus 18. And again, I have some like terms to combine. So put those together. 2x squared minus 4x minus 16. And I am finally done. That is my equation. I guess I should call it f of x in polynomial form. So it does take longer when you have an A. There's not going to be too many of those, I hope, on the test, but you guys can do that. So now that we have it in polynomial form, we can rewrite it in intercept form. And I know it feels like we just distributed that 2, but the first thing we're going to do is we're going to factor that 2 out. It's not going to be exactly the opposite of what we just did, even though it feels like it. So I'm going to start by rewriting my equation here. All right, so the first thing we're going to do is factor that a out. So I'm going to just remind myself that I'm dividing all of these by 2. We're going to divide all of them by 2, and that means we'll bring the 2 out front. So it'll be 2 on the outside, and then x squared minus 2x minus 8. So we divided all 3 terms by 2 so we could bring the 2 out in front. All right, then when we do the big X, we do the big X on what's inside my parentheses. So the negative 8 goes on top and the negative 2 on the bottom. We've seen this one before. 2 things that multiply to 8 are going to be 4 and 2. One of them has to be negative. It's going to be the negative 4. All right, so our function, one thing you have to remember here is this 2 is still here. This 2 is still there, so we can't forget about it. So it's still in front. It's our a in our intercept form. And we have x minus 4, and then our x plus 2 from our big X. So there is our equation in intercept form. And then we can go ahead and find our intercepts. That's the easy part. You guys are great at that. Is take the opposite of each of those numbers in the parentheses. We'll have positive 4 comma 0 and negative 2 comma 0. All right, again, pause and try to do the next one on your own, but I'm just going to go ahead and go through it. All right, so finding our vertex, it will be at positive 7 comma 48. And then, oh, I guess that was in this box. All right. Okay, so now we're going to rewrite the function in polynomial form. I'm going to bring it down here so I see what I'm doing. So do my expansion here. And remember, just keep everything. Sometimes it's tempting to leave this negative 3 off and think, oh, I'll come back and remember it's there later. But it's easy to forget. So if you keep it there at every step, then you're less likely to forget it. All right, so when I do this, when I multiply these 2 together, I get x squared minus 7x plus 49 plus 48. All right. Then we have to distribute the negative 3. Oh, actually, you know what? Before I do that, I'm going to combine some terms here. I have these 2 negative 7s. Let's put those together first. So keep everything else the same. All right. All right, now let's distribute. So we'll take that negative 3 and we'll multiply it by each of these pieces. I'm running out of room, so hopefully I can fit this all in here. So negative 3x squared, negative 3 times 14 is going to be 42, positive 42, because it's 2 negatives, 42x. And then 49 times 3, and it's a negative 3 times a positive 49, is going to be 147, but negative. So negative 147, and then I still have this 48 over here. All right. So hopefully I'm doing this right. The numbers are getting big here, so I'm got to pull out my calculator. All right, so now we're almost there. We still have a couple terms to combine. Right here are constants at the end. So 147, negative 147 plus 48 is going to be negative 99. and everything else will stay the same. So negative 3x squared plus 42x minus 99. So there we go. There's my equation in polynomial form. Hopefully this isn't too tricky when we put it in intercept form, because that's what we're going to do next. All right, so let's rewrite it down here. F of x equals negative 3x squared plus 42x minus 99. All right, so we are going to divide everything, remember, by 3, negative 3. So when we do that, that means we can pull the 3 out front. So inside our parentheses, we'll have x squared minus 14x plus 33. Okay, so now for our big X, we're going to put 33 on the top and negative 14 on the bottom. And I know those numbers look scary, but I think it's going to work out. All right, so 33. What multiplies to 33? Well, always 1 and 33. Always start there. It's not 2 and anything, 3 and 11. And I think that's pretty much it. So, but looks like 3 and 11 is going to work for us. They're either going to both be positive or they both have to be negative to make that negative 14. So it looks scary, but they're not that bad. So those are our numbers. So our function f of x is going to equal negative 3, and then x minus 3, x minus 11. All right, I should have put that a little lower so I had more space. So there we go. That's our intercept form. And then we can find our intercepts. They're going to be at the points 3, 0, and 11, 0. All right, let's move on to the next one. Okay, so number 5. So now they're giving us the function in intercept form. So first thing they want us to do is find the intercepts. Again, this should be easy. Take the opposite of both, negative 3, 0, and 5, 0. Okay, and they want us to rewrite it in polynomial form. So whenever we want to go to polynomial form, we always are going to be multiplying and simplifying. So let's rewrite what we have. X plus 3 and x minus 5. And just because I want to mix things up here, I'm going to do the box method here. So on the top, I'll put my x plus 3, and on the side here, my x minus 5. And I can fill in all my boxes. So these two are like terms, so they'll combine, and all together I have f of x equals x squared. Negative 5 plus 3 is going to be minus 2x minus 15. And that is it. So as you can see, it's a lot easier when you don't have an a. So there's my equation in polynomial form. And now, of course, they want us to put it in vertex form. So to get it in vertex form, and it tells you here, it may not tell you on the test, so you're going to need to know that to get to vertex form, you want to complete the square. So to complete the square, let me rewrite where I'm starting from. So to complete the square, I'm looking at this number here, and I want to find my half. And I always put them off to the side over here. I know some of you don't like writing it. I feel like if you write it, then you don't get lost. It's easy to forget it if you don't. So half of negative 2 is negative 1, and negative 1 squared is positive 1. So that's my half and my square. All right. Then I'm going to, let's see. I'm going to put my parentheses on there. That's one way to do it. And then in my parentheses, so keep everything the same, and then in my parentheses, add my square and subtract my square. And then I still have my minus 15 out here. And then our goal is always to get this negative square out of the parentheses. In this case, because we do not have, there's no a here, there's nothing to multiply by it before we bring it out. This is the easy version, but I'm still kind of trying to keep it consistent. There's nothing to multiply it by, so we can just bring it out, so that -1 just comes out as a -1. So then we rewrite what we have, and we have x squared minus 2x plus 1 inside our parentheses. On the outside, we have -15 and -1. So this piece right here, that's what's our perfect square. It's what gets rewritten as x. We look at our half, and our half is -1, so it's x minus 1 squared. If you forget how that works or why that works, just remember that you could look at this right here and you could factor it. You could use the big X and factor it, but it's going to factor to this. That's kind of like the magic of completing the square and why we do the process, why we added that 1. It's to make it work so that we can change it to this. So this is kind of like our big parentheses expanded, and we're putting it into our squared form. All right, and then we just want to also combine our constants on the outside, so that'll be -16. All right, so this is our equation in vertex form. Okay, so now that we have our equation in vertex form, we can find our vertex. It is going to be at the point 1, -16. Because we always change the h, we change what's in the parentheses with the x, and what's outside the parentheses we leave the same. All right, again, I challenge you to do the next one on your own. All right, intercepts are -2, 0, and +10, 0. We're going to rewrite in polynomial form. So I'm going to use, well, we already did the box. We'll do the regular way, the boring way, x plus 2, x minus 10. So the x gets multiplied by the x and by the -10. So that's x squared minus 10x. And then the -2 gets multiplied by the x, and the -2 gets multiplied by the -10. So that's plus 2x minus 20. Combine these like terms in the middle, and we have x squared minus x squared minus 8x minus 20. For some reason I feel like that's not right, but that's right. Okay, so that is our function in polynomial form. So we answer a question, we can box it and move on. All right, now that we have it in polynomial form, of course they want us to complete the square to put it in vertex form. So I'm going to look at my b. My half is going to equal -4, and my square is going to equal +16. Sometimes I write them that way. All right. F of x equals x squared minus 8x plus 16 minus 16 minus 20. Remember, we want to get this -16 out. We're allowed to just bring it right out since we don't have anything in front. There's nothing here, so we're okay. F of x equals x squared minus 8x plus 16. And then on the outside, -20, -16. All right, so all of this gets rewritten as x minus 4 squared. And so remember, we can look at either our half to know what that number is there, or again, we can just know it's half of what this is here. So it's going to be x minus 4. And then on the outside, our constants are -36. Okay, there is our vertex form. So then we can go ahead and write our vertex at the point +4, -36. All right, next page. So now they're going to give it to us in intercept form, and same thing. Oh, we just did that, but now these are the harder intercept forms. So again, as you see, we have a 2 in front, -2 in front. We have the a in front. So it's just going to be a little bit more work, but same process. All right, so first find the intercepts though. Our intercepts are going to be at positive 1 comma 0 and positive 5 comma 0. Okay, rewrite it in polynomial form. They're not quite as bad as the other ones. So it equals negative 2, x minus 1, x minus 5. So same thing. First thing we're going to do is expand this out. So we still have our negative 2 out front. Keep that there the whole time. So x times x, x squared, x times negative 5 minus 5x. Do the negative 1 to everything, negative 1 to the x, and negative 1 to the negative 5. So we have minus x and then positive 5. All right. Let's combine these terms. X squared minus 6x plus 5. And then we can distribute. So whenever you have an a in front, you're going to end up distributing at some point. Negative 2x squared plus 12x minus 10. And we are all the way in polynomial form. We don't have anything else to combine or simplify, so we are done. There's our polynomial form. All right, now they want us to go to vertex form, so we're going to have to complete the square. Again, the completing the square is going to be a little trickier because we have that a in front. So let's rewrite our equation down here. So in this case, if you remember, we factor the a out of the first two terms. So that means we're only dividing it out of these two terms. So I'm going to bring the 2 out front, and when I divide this first term, I'm left with x squared. When I divide the next one, I'm left with minus 6x. The negative 10 stays out here by itself. All right. Then the other tricky thing is we got to remember that the half, when we find our half, it's the half of this new thing. We're not looking at the 12. We're looking at the 6. And so sometimes that feels like we're taking the half twice, especially when we divided by negative 2 because we were factoring it. But just remember that you're not taking the half until you get to this point where you've already factored your a out. So our b is not 12, our b is negative 6. That's where we're looking. So half of our b, our half over here equals negative 3. And our square equals 9. All right. So then keep our negative 2, x squared minus 6x, add and subtract our square. So add 9, subtract 9, and the negative 10. All right, so here's where we want to bring this 9 out, but we can't until we multiply by the negative 2. So negative 2 times negative 9 is positive 18. So together that will become a positive 18. But that does not mean that our negative 2 goes away. It's still there because it's still being multiplied to everything else that's left in the parentheses, which is all of that. That's our perfect square. All right. So then at this point, we have our perfect square we can rewrite. Still don't forget your negative 2. It's still there. Our perfect square gets rewritten as x minus 3 squared. Remember, again, we can look at our half, or we can just look right above it. And then what's left, our constants outside, is positive 8. All right, so there's our equation in vertex form. And we can, yep, they want us to find the vertex. So our vertex is the point 3, 8. All right, so again, try the next one. See if you can get it on your own, and then come back and check. All right, so first find the x-intercepts. They're going to be at negative 2, 0, and negative 12, 0. All right, this one's got some big numbers. I bet it's going to be fun. All right, so let's see. Ooh. All right, so, sorry, my palm keeps moving it. 6 times x plus 2 times x plus 12. Okay. And why not do the box here? Let's do the box. X plus 2, x plus 12. So this is x squared. This is 2x. This is 12x, and this is 24. All right, so these are our like terms in the middle. So when we write it all out, remember we still have the 6, and in the middle we have x squared plus 14x plus 24. All right, so now we get to distribute this 6 to everything. And so we have 6x squared plus, all right, 6 times 14 is going to be 84. 84x plus 6 times 24, 144. All right, I don't think we have anything left to combine, so we are done. That is our equation in polynomial form. All right, so now we are going to put it in vertex form. So I'm going to rewrite it again here so we can remember where we're at. Okay, f of x equals 6x squared plus 84x plus 144. So again, it seems like we just multiplied that 6 in. Now we're going to divide it out, but we're not dividing it out of everything. We are just dividing it out of the first two terms. So we pull it out of those first two terms. So we're left with x squared plus, it was 14x there. And this 144 stays out on its own. All right, so then our half, we're looking at half of 14. So our half, where should I write it? I write it up at the top. My half equals 7, and my square equals 49. All right, so 6x squared plus 14x plus 49 minus 49 plus 144. All right, so now we got to get this negative 49 out of here, but to do that we got to multiply by the 6 first. So 6 times negative 149, or not negative, yeah, not 149, just 49. 6 times negative 49 is 296. That makes sense. Okay, so negative 294. Hopefully you guys are following along and checking my work. Yep, 294. All right, so let's rewrite what we have. We have 6x squared plus 14x plus 49. There's my perfect square there. And on the outside we have plus 144 minus 294. All right. Okay, good. We still have some room here. Okay, so we're going to rewrite our perfect square as 6 on the outside. On the inside, it's x plus 7 squared. And out here we have 150, negative 150. All right, that's a big number, but we're going to trust it that we did it right. All right, so that is our equation in vertex form. So now we can go ahead and write our vertex. And our vertex is going to be the point negative 7, comma, negative 150. All right, let's see how close we are to the end. Oh, now they're starting in polynomial form, and we get to do the same thing. All right, so we're starting in polynomial form, and we're not going to find any info in polynomial form. We're just going to go straight to the other forms. So we're going to go to vertex form, and we're going to do that by completing the square. This is an easy one because there's no a, so we're just going to find our half. My half equals half of 2 is 1. And then my square equals 1 squared is 1. So I'm going to add and subtract my square. plus 1, minus 80 on the outside. So then I want to get this negative 1 out. Because there's no a, I'm just allowed to take it out. Okay, I can rewrite my perfect square right here. And it's rewritten as x plus 1. Again, you can look at your half to see that, or you can look right here at your half to see that, or you can just see what half of this is, and that's how you know to rewrite it. And then my constants over here at the end, negative 80, subtract 1 is minus 81. All right, so I am now in vertex form. In vertex form, they're going to ask for the vertex, and it's going to be at the point negative 1, comma, negative 81. All right, now they want me to write it in intercept form. Something to remember here is you got to go back to polynomial form. We don't have to, we already have it in polynomial form way up here. So we just have to look at what they gave us at the top and use that. So remember, we can't go from vertex form to intercept form. We got to have polynomial form, but we already have it. So we're just going to look at what they gave us, x squared plus 2x minus 80. So it's x squared plus 2x minus 80. Let me just make sure I wrote that right. Yep. All right. So we're going to do the big X. It's going to be big because 80 is big. Negative 80 on the top, 2 on the bottom. All right, so 1 and 80, 2 and 40, 4 and 20, 5 and 16, 8 and 10, and I think that's all of them, and I think it's this last one at the bottom we need, 8 and 10, because those are 2 apart. So 8 and 10, one of them's got to be negative, it's going to be that 8. So we are going to rewrite this as f of x equals x minus 8 times x plus 10. And that is our equation in intercept form. So now we can use that and find our intercepts at the at positive 8 comma 0 and negative 10 comma 0. All right, you try the next one on your own before you watch. All right, so again, starting from polynomial form, we're not going to find any key info. We're just going to go straight to vertex form by completing the square. Our half is going to be negative 7. And our square is going to be positive 49. X squared minus 14x plus 49 minus 49 plus 48. Okay, we want to move this out. We are allowed to do that since we don't have an a. X squared minus 14. And if you guys do this in fewer steps, that's okay with me. I'm just showing you all the steps so that you aren't confused with what's going on. Plus 48 and then minus our 49. All right, we can rewrite our perfect square right there. And it is x minus 7 squared, and our constants on the outside, minus 1. All right, and that is it. We are done. So we have our vertex at the point 7 comma negative 1. All right, now we want to go to intercept form, which, remember, that means we have to go back and get our polynomial form from the top. X squared minus 14x plus 48. All right, x squared minus 14x plus 48. All right, big X, 48, negative 14. Things that multiply to 48. 1 and 48, 2, 24. I think it's 3 and 16. And if you can't think of all of these, that's fine. You know, think the ones you think of, and, you know, maybe you'll get it without thinking of all of them. 4 and 12, 6 and 8, and it's 6 and 8. 6 and 8 add to 14. They both got to be negative. So they'll multiply to a positive, but they'll add to a negative. All right, so f of x equals x minus 6 times x minus 8. Equation in intercept form, because that's what they asked for. And then down here, they asked for the intercepts. They'll be at the point 6, 0, and 8, 0. All right. We're getting to the home stretch, except these are a little bit harder because, again, now we have a's. So to go from polynomial to vertex, completing the square, remember we have an a. So we've already done this, but this is just more practice. We are going to factor out that a. So I'm going to write my equation here. All right, so we are going to, remember, we're only going to factor it out of the first two terms. We're going to divide the first one by 3 and the second one by 3 and bring it out here. So that'll be an x squared. That will be a minus 8x. The 21 stays outside the parentheses. All right. So now, again, the important thing to remember is that this is the b you're looking at. Our b is negative 8. So when we find our half equals negative 4. This is, again, one reason I always write it is because if you don't write it, you might come back later and look at that negative 24 and get confused. So if you write it now, then hopefully you won't get confused. And then our square is positive 16. All right. So we're going to add and subtract our square. We want to bring our negative 16 out, but we got to multiply it by the 3 first. So that's negative 48. So let's keep everything the same here. The 3 still stays. It doesn't go anywhere because it's still multiplied by everything else in the parentheses. But out here we have 21 minus 48. All right, we can rewrite our perfect square. Keep the 3 though still. X minus 4 squared. And, oh, that was a plus 21. Somehow I lost that it was plus. All right, plus 21 minus 48. That will be minus 27, I think. Yep. All right, so there's my equation in vertex form. All right, so identify the vertex now. The vertex will be at the point 4, negative 27. Right, now we want it in intercept form, which means we have to go back and grab our polynomial equation because that's where we start. Our polynomial equation was f of x equals 3x squared minus 24x plus 21. Let's double check on that. Yep, that is our polynomial equation. All right, so to go to intercept equation, we are going to divide every term by the 3 because we're factoring the 3 out of everything. So it'll be x squared minus 8x plus 7. Okay, and then we're going to do the big X and what's inside our parentheses, 7 on the top, negative 8 down here. There's only 2 things that multiply to 7 because it's prime. So it's got to be 1 and 7. Those are our only choices, except for they can be positive or negative, and they have to be negative to get negative 8. So our equation will be f of x equals, we got to keep our 3, don't lose your 3, x minus 1, x minus 7. So yeah, don't forget your 3. It's still part of your equation. It's still there. All right, so now we can write we can find our intercepts, and we have 1, 0, and 7, 0. All right, next one, try on your own. Okay, so we are going to go to vertex form, so we're going to complete the square. We want to factor that 2 out of the first two terms, but leave the 64 alone. Look at this new b for finding our half. So our half will be -6, and our square will be 36. All right. Okay, we want to get this 36 out of my parentheses, but we got to multiply it by the 2 first. So that's going to be -72. All right, f of x equals, oh, don't forget the 2. 2 stays, x squared minus 12x plus 36. And then outside my parentheses, I have the difference between 64 and 72. I'm getting tired. That is 8, -8. All right, so I can rewrite my perfect square, what's in my parentheses. That gets rewritten as x minus 6 squared minus 8. Okay, so we wrote it in vertex form. Now we can find our vertex. Our vertex is the point 6, -8. And now they want intercept form, so we have to go back and find our original polynomial equation. It was f of x equals 2x squared minus 24x plus 64. All right, so here's our original polynomial equation. We are going to divide, we're going to factor out the 2. So I'm going to divide everything by 2 so I can bring it out front. I have x squared minus 12x plus 34. All right, and we've done this big X before, not 34, 32. All right, so 32 on the top, -12 on the bottom. We've done this one before. Two things that multiply to 32 are 8 and 4, and they both got to be negative. So our f of x equals 2, because we don't want to forget, remember we don't want to forget our a. 2 x minus 8, x minus 4. All right, there we are in intercept form, and we can find our intercepts. They will be at 8, 0 and 4, 0. All right, I know this video is long. All right, so now we are on to the word problems. We are really almost done now. So first one, so a ball is thrown upward. It's got initial velocity, and it's starting from a height of 160. We gave you the equation. One thing I noticed is that we gave you the wrong equation. This should be a 0 because that was our initial height was 160, and that's where that comes from. So, sorry, hopefully we get that fixed before you look at it. So what are we looking for? So we're looking for the ball's maximum height. Maximum height's going to tell me I want to find the vertex. And then the other question is how long until it hits the ground. So until it hits the ground, that's our x-intercept we're going to look for. So to find those things, we are going to go to Desmos, and we are going to graph this equation. So let's pull up Desmos, and let's put in our equation. So -16 x squared plus 48 x plus 160. All right, and I'm gonna give it a full screen now. So we wanted to find the vertex, and the vertex is at the point 1.5, 196. So my vertex is at the point 1.5, 196. So that's my vertex, but I need to know how to interpret that. So the maximum height is that the 1.5 or is that the 196? Well, the 1.5 is the time at which it reaches the maximum height, and the maximum height is the 196. So the maximum height is 196 feet. So that's the first part of the question. It actually doesn't ask us when it reaches that. So we don't need the 1.5 seconds. They do not want that on this question, I guess. So we just need to answer the 196 feet. The second part of the question is how long until it hits the ground? And again, remember the clue on that is that we're looking for the x-intercept. So if we go back to our picture, we look down to our x-intercept, it is at the point 5, 0. So the height is 0. In other words, it's hitting the ground at 5 seconds. So our answer to that one will be 5 seconds. So 2 questions, 2 answers from 2 different parts of the graph. All right. The next one, a water balloon is dropped from a building. What is the balloon's height after 2 seconds and how long until it hits the ground? So let's go, oh, my equation's down here now. Okay, so, all right, so my equation is -16 x squared plus 576. Double check that I put everything in right. Okay, I'm gonna get more screen. Now I gotta find it. Where is it? There it is. Okay. So, if you're ever dropped straight from something without being thrown, you're gonna be right centered on your y-axis. So the question didn't say anything about a maximum height because the maximum height is going to be where you started, right? Because you started, you dropped it, you didn't throw it up. So it didn't ask about the maximum height. It did ask what is its height after 2 seconds. So after 2 seconds, that means when time is 2 seconds. So time is x. So I'm going to just go ahead and write x equals 2. And that's going to give me another line. And I can see at 2 seconds, if I can find where they touch by just kind of touching near it, at 2 seconds, it's going to have a height of 512 feet. So that's my first question. Is it, what's the height after 2 seconds? And it is 512 feet. The second question is how long until it hits the ground? And remember to find that, what we're looking for is the intercept. So scroll all the way down, zoom out a little bit. I know it can take time to do this, but scroll out. I'm going to get rid of my line that I don't need anymore. And touch there, find our intercept. Our x-intercept is 6. So at 6 seconds is when it's going to hit the ground. So it's kind of interesting that it's still pretty high after, it takes it 2 seconds to get down to that level. Yep. Okay, that makes sense. All right, so 6 seconds is when it hits the ground. I was going to use a different color, but I can't get to my pen right now. Okay, hits the ground at 6 seconds. All right, so we answered both parts of that. Let's go. We'll get rid of the Desmos for now. All right, let's go. So those are the physics problems. You always are going to use almost that same equation, that -16x squared. If you're looking for a max height, you're going to use the vertex. If you're looking for when it hits the ground, you're going to use an x-intercept. And then if you're looking for it at a specific point, you're going to just plug in that point. All right, let's go to business, finance. So a toaster company has determined that its weekly cost function is this equation. So C of x is the cost per toaster, and x is the number of toasters made. How many toasters should be made to minimize cost? And then what is that cost? So really, they're just looking for one thing. They want to know how to minimize cost. Minimize is a vertex question. We want the vertex. So we're going to take our equation, put it into Desmos, and find our vertex. So our equation is 0.05 x squared minus 8x plus 350. Okay. see if I can find where my picture is. There it is. Okay, so we want to minimize costs. So we want, it makes sense, the vertex is down low. We want to minimize it. Our vertex is at the point 80, 30. Okay, so 80, 30 is the vertex, but we have to answer the question. What does that mean? Well, this 80 is going to be the number of toasters, because that's our x, and x is the number of toasters. And then the 30 is going to be the cost per toaster. Cost per toaster. Okay, so answering the question, how many toasters should be made to minimize cost? They should make 80 toasters. And what is the cost? The cost is going to be $30. So those are your two answers to that question. All right, next one. A shoe company has determined its profit for its newest shoe style is this equation here. So P of X is the profit earned, and X is the number of pairs it makes and sells. So what is the first break-even point for these shoes? And then also find the maximum profit. So we have two different questions, the break-even point and the maximum profit. So first thing though, let's get our equation on here. Negative 15x squared plus 2250x minus, 81,000. All right, did I enter that in right? Let me double check. It's always good to double check. Okay, negative 15x squared, 2,250x, and minus 81, and how many zeros? Yep, 3 zeros. All right, so there's my equation. So the first question is break-even point. And remember, break-even point means x-intercept. So we're going to go, let's look for that point first. And it says the first break-even point. So we want the first x-intercept because we have two of them. So we want the first one. So when they sell 60 pairs of shoes, they break even. So let us write that. So our first break-even point, always answer in words, break-even point is at 60 pairs of shoes. Okay, the next question is find the maximum profit. So maximum is a vertex question, so we're going to go up here, way up here. It's a very weird graph. I don't think it's very accurate to a real situation, but that's okay. Their maximum profit is when they sell, remember the first number is the pairs of shoes. The X is the number of shoes that they sell. So when they sell 75 shoes, their profit, so they want the maximum profit. I guess that could make sense. Their maximum profit is $3,375. And they don't ask how many shoes to sell to get that maximum profit. They just want to know what the maximum profit is. So we're just going to give them that number. All right, so those are the two answers to that question. And I think we are finally done. So if you are still with me, good job. Good luck on the test, and I will see you later.